Hi, this is TomReardon, math teacher from Ohio. We're answering the question, why TI Inspire CX? This is a geometry activity called area formulas. We're going to be emulating this with the TI Inspire CX emulator software, but whatever you see will look just like it would on a student's handheld. You'll notice that the Inspire CX handheld and software are now in beautiful color. Why Inspire CX? It is a learning tool and a teaching tool. It is no longer just a graphing calculator with a touchpad, and now it's in color. Geometry students often have a difficult time understanding the area formulas for geometric figures. With TI Inspire CX, students can discover these formulas for themselves. Watch. Again, we'll be simulating what a student would be doing on a handheld. This is the first page explaining what we'll be doing. So I'll click to the next page. And it says click the up arrow to show the dimension label. So the student would move the cursor to click here, and you can see that it's base and height as opposed to length and width, and you'll see why we would want that. Click on to page 1.3, and we want to talk about finding the area formula for a parallelogram. We're going to look at a rectangle and a parallelogram with the same base, same height. Go on to the next page. To emphasize that, the student would be asked to grab point H as I'm doing here and move it up or down, and you can see that the parallelogram and the rectangle always have the same base, the same height, and then we can grab the B and see that they always have the same base. But here's the real cool part is the students are then instructed to grab point P and pull it as far to the right as they possibly can. And you can see what happens is the parallelogram actually is really a rectangle, and so it has the same formula, base times height. Moving on to the next page, we're going to talk about area of a triangle. We're going to have a triangle and a parallelogram that have the same base and same height. You can see that, and again, we can grab the H and change the height. We can grab the B and change the base. But again, they're asked this time to grab point Q and grab it and pull it up and over as far as they can, all the way over. And you can see that these two triangles take up the same area as this one parallelogram. The area of the parallelogram is base times height, so the triangle is half the base times the height. And the students are discovering this on their own, not me just telling them. And I remember my students often telling me, why'd you put a fraction in the formula? And I didn't put it in there, it just belongs there. Finally, we're going to look at the area of a trapezoid formula. On this page, they have this same height but different bases. The students are asked to grab point R and pull it up and all the way around. And when they do that, you can see that these two trapezoids make up the same area of this parallelogram. The area of the parallelogram is base 1 plus base 2 times the height, so the trapezoid is half the height times the sum of the bases, which is exactly the formula that they're supposed to get. And the students are discovering this on their own, and when they come up with on their own, they feel like they have ownership, and they usually remember it longer. So to summarize, here we have the area formula. You can see what we did there. The area formula for the triangle and the area formula for the trapezoid. This concludes this